Hello everyone, I am Mrs. D. Shanti Chalaya, working as Assistant Professor in EC Department at Sri Muthukumaran Institute of Technology. In this video, I am going to take operational amplifiers, basic characteristics and its principles. An operational amplifier, it is also called as op-amp, is a versatile high-gain direct coupled voltage amplifier with differential input. It is used as a fundamental building block in wide array of analog electronic circuits. It is a high-gain electronic voltage amplifier. It amplifies the difference between two input voltages given at its two input terminals. It is widely used in circuits such as amplifiers, filters, and comparators. Now we will discuss the basic characteristics of op-amp, which is nothing but the operational amplifiers. It has very high voltage gain, it has very high input impedance and low input output impedance. The differential input, and it has a single ended output, meaning is it has two inputs and one output with the power supply positive and negative power supply. Now this is the ideal characteristics of the op-amp. Now the ideal characteristics of op-amp are practically not possible, but typically it is considered to simplify the circuit analysis. The basic characteristics are infinite open loop gain, which is it amplifies the input difference infinitely. Practically it is very high, 100 million plus. Next is infinite input impedance, that is no current flows into the input terminal, that is it prevents the loading of source circuit. It has zero output impedance. It can supply any amount of current to the load without voltage drop. Thus it acts as perfect voltage source. Then infinite bandwidth. It can amplify any frequency signal from DC to infinity without attenuation. It has zero input offset voltage. Output is exactly zero when both input voltages are equal. Practical with ideal op-amp. Practical op-amps have finite gain and bandwidth, where ideal op-amp have infinite gain. Practical op-amps high input impedance in the order of 2 megaohms for BJT up to 1.11 ohms for FET, 1 tetra ohms for FET. Then for low output impedance for practical op-amp, zero output impedance for ideal op-amp. Considering bandwidth, limited bandwidth approximately 1 megahertz to 1.5 megahertz practically, whereas it is infinite for ideal. Considering the CMRR, common mode rejection ratio, it is very high but finite, 70 dB to 120 dB, whereas it is infinite for ideal op-amp. Slew rate, it is limited, example 0.5 volt per microsecond for IC741, whereas it's infinite for practical op-amp. Output swing is limited by the supply voltages. Will test the description of general op-amp stages, which is the internal block description of an op-amp. It consists of four stages: input differential amplifier stage, intermediate stage, level shifting stage, and output power stage. The general characteristic of an op-amp is two input terminals are given, which is non-inverting input, one inverting input, and one output is taken. So to maintain the difference between the two input voltages uh, in, as minimum, and the output as an amplified output voltage, the internal block description is given as shown in the figure. First is the input stage, which is the differential amplifier. It consists of a dual input balanced output differential amplifier. Its purpose is to provide the initial voltage gain and establish the high input impedance of the op-amp. It performs CMRR, meaning it amplifies the difference between the two inputs while rejecting the noise common to both. Next block is the intermediate stage, which is dual input and unbalanced output, that is single output differential amplifier. It consists of one or more additional differential amplifiers or a common emitter or common source amplifier. Its purpose is to provide additional high voltage gain as a single stage is often insufficient for ideal amplification. Next is the block level shifting stage, because the three stages are direct coupled. DC voltage and output of the intermediate stage is usually well outdated. The purpose of the stage is to boost level traffic to push the signal downward to 0 volt with steady down. This ensures that output can swing both positive and negative with good DC offset. Last stage is the output stage, which consists of rich full gas amplifier cut-off stages to provide high current gain and low output impedance. The function is to allow the op-amp to drive external loads efficiently without affecting the internal gain stages. The input differential amplifier stage amplifies the difference between input signal. It provides high input impedance. It reduces noise and common mode signals as described earlier. The intermediate gain stage, which provides most of the voltage gain, it increases overall amplifier gain and it often uses active loads. A level shifting stage, which adjusts the DC voltage of the signal before it reaches the final output stage. The level shifter brings this accumulated DC level down to the 0 volt, thus maintaining zero offset and the uniform swing between positive and negative with reference to the DC signal. Final stage is the output stage, which provides the low output impedance. It supplies required current to the load successive to the output stage, and it is usually designed using a push-pull or class AB stage, and output is the amplified output of the input signal. The common available op-amp IC is IC741. It is one of the earliest and most popular op-amp. It is introduced by the company Fairchild Semiconductor. It is a general purpose op-amp and it consists of an 8-pin IC with a flat type or metal can type. The internal circuit diagram of IC741 op-amp is a complex network of approximately 20 transistors and 11 resistors integrated onto a single monolithic silicon chip as shown in the figure, which is the top view of the dual line package of IC741. It is typically divided into four main stages: input stage, differential input stage, intermediate stage, which is designed as current mirror, and high gain voltage amplifier stage, and last stage, output buffer stage. Input stage is a differential amplifier which consists of Q1 through Q7. Intermediate stage, it consists of transistors Q16 and Q17, and level shifting stage utilizes transistors Q16, and output stage complementary push-pull amplifier which consists of transistors Q14 to Q20, and short circuit protection is given by the transistors Q15 and Q22. The biasing and current mirrors which is provided in the op-amp is to establish stable reference current and active loads for internal stages, ensuring consistent performance despite of power supply fluctuations. And here the IC diagram is shown with a pin configuration with pin numbers from 1 to 8. So two input terminals, inverting and non-inverting, indicated as minus and plus, is given as the pin number 2 and 3, and out is single output terminal which is given as pin number 6. Then also V plus and V minus to pin number 4 and pin number respectively. And offset null compensation is achieved using the pins 1 and 5. And each pin is no connection, meaning that it can be used for any future circuit description. The key features of IC741 are high voltage, which offers very high open loop voltage gain, typically in the order of 200 volt per volt, that is 100 dB at low frequencies. High input impedance in the order of 2 mega ohms. It draws very little current from the input source. Low output impedance in the order of around 75 ohms, enabling it to drive various loads efficiently. Then internal frequency compensation is achieved by a built-in 30 picofarad capacitor which provides internal frequency compensation, which helps to stabilize the circuit and prevent unwanted oscillations without needing external components. Then short circuit protection is achieved using the output stage, which includes internal circuit that provide overload and short circuit protection, which safeguards the device from damage. And in addition to this, we have offset voltage null capability, which is it has a dedicated offset null pins, pin number 1 and 5, that allow for the manual adjustment to eliminate the input offset voltage and balance the inputs. Wide supply voltage range, which means that it can operate across wide range of dual power supply in the range plus or minus 5 volt to plus or minus 15 volt, and moderate slew rate at the rate of 0.5 volt per microsecond, which indicates how quickly the output voltage can change when the input is changed. While moderate compared to modern high-speed op-amp, this is sufficient for many general purpose op-amp applications up to 1 megahertz. So now the applications of op-amp are given as in inverting and non-inverting amplifiers, integrators and differentiators, active filter, signal conditioning, and some arithmetic circuit used as summer and subtractor, adder. So in many applications which corresponds to linear functions, these op-amps are used, and it is used in building the analog system. Thank you.